In the communication architecture, we have four main components, which are the PLC, local node-RED, cloud services, and SCADA. The SCADA system has a dashboard where the user can visualize the system's operation and interact to send commands to the PLC. It is connected to the cloud, where we find two services, Node-RED and Watson, which are in constant communication with the local Node-RED for data acquisition from the PLC.
We have here a speed variator, which is connected to digital output of our pack and a common point. This variator has an analog output that goes to the motor for increase or decrease the RPM. The variator, the parameters of variator that program this automatic startup. This is P46, P48, and 15. These parameters are set up in option 2 like this. We can see option 2 in parameter 46 of variator.
In our local PLC, we have a little letter code that control the factory plan that we are seeing. Stop. We have a little vision sensor where we identify the piece that we are working on, and we are using a little. We have a little speed variator controlled by this subroutine, where we have control of velocity from 1 to 10 to 9, and we have a little security specification, so the band never go slower to stop, slower enough to stop. Okay. Now we're seeing our SCADA platform. It is on the cloud in Node-RED by Azure, and we have to put first our plan here in automatic mode. I'm sorry, moment. Make it display. Put it in automatic, and then we from cloud give them on a start. Now we see in our routine the exit conveyor is represented by our motor with our velocity variator, and here we can change the velocity of work, the work velocity, sorry. So we can go slower, and it is on both here in our motor and in the simulation in factory, or we can go faster. Now we are going on max velocity. As you can see, also we can see the velocity of our exit conveyor, the actuators, sensors, the operation mode, and a speed alarm for a correct production.
Can put stop here in our panel control panel, and after that our motor is stopped and the frequency of our variator is the same as before. Here in factory U we can put the emergency stop, so our variator is turned off. So we have here our SCADA from our plant. So in the first part we have a control panel. We have here a greeting message. We have the stop button, the start button, and we have here our RPMs slider, so we can change our frequency, the frequency of our motor with this slider. Here we have our actuators. We have 3 belts or conveyors and 3 selectors. After that, we can see here the one gauge for our motor and the state of our second conveyor. Here in historics we have how many boxes was passed through our sensor. We have here also the velocity of our conveyor. We can here see the change between the time. We can see here the hour, and after that we have the sensors. We have 2 sensors. The first one is a vision sensor that identify what kind of piece was passed through the sensor, and we have this sensor at exit that look if one box passed through one specific point. After that we have our operation mode. We have auto and manual mode, and we have an alarm. That alarm is for when the speed of the van is too high, so we can see here our LED turn on when that happens. And that's all about our SCADA panel.
Now we are presenting the part of the connection between the SCADA Nube and the cloud computation from Azure and the local SCADA in Node-RED that works as a gateway. So here we have the SCADA that works as a gateway. Here we have the calculation for proofs here, and here we have how are compiled are the tags from the PLC in the lab from Rockwell Systems. Here we have to name all the tasks correct properly. Then we can send the signals through Watson IoT. Watson IoT allows you to send events from a device. This device sends signals when this signal changes from one state to another. Here we have how to connect it through the credentials. For that we have to create here our device, and with that device we are allowed to send information to the Node-RED Nube. This Node-RED Nube was created with the help of the Azure, Microsoft Azure. We have used the containers from Azure. We have containerized Node-RED. With that Node-RED containerized, we can allow use to work in the cloud computation from Microsoft. That means that we can work without have the tabs open, just with the with the flow created, and that is all. Then with that, for that Watson Yote from local, we have to create an API and a token here in Watson EVM, here in apps. That is for allow you to receive the information. That means write information from the Node-RED local to the Node-RED Nube. Thus, we can work our signals. Here we have worked the signal to elaborate our SCADA that is here. We have tags from the actuators, for sensors, how it works in the plant. We have also signals of status and precaution, yes, as this from speed in the motor. Also we have the historicals and the panel control. So here we can send the signals from red with these three. We have worked it from our dash, and thus we send it to the tag as in the same way as we have do it in the local SCADA, that is this one. So we have the node for send the signals. Here we have the node for send the signal from SCADA in the cloud computation to the node-RED in the as a gateway, and we receive the signals here from in the same way as in the SCADA in the cloud computation from Nature, and that is how works the connection.